all, my name is Lee and welcome to the channel. So I have a really exciting project for you today. It's a small oscillating steam engine that you can build the entire thing with just the lathe, a 3-jaw chuck, maybe a 4-jaw chuck and just a hand drill. I don't have a pillar drill, my one broke, and I still haven't bought a milling machine yet. So all of this can be done with a lathe and with a normal hand drill. So what I'll do is I'll take you on a closer look of my little test rig, which is just here. And I've also already built the parts, but what I'll do is I'll take you through how I built the parts and how I positioned them on the lathe to get all of the different holes and cuts, etc. So let's take a closer look. So I'm actually running mine off of compressed air rather than steam, but obviously this can be modified to use a steam if you have a small boiler. I might make a small boiler in another video, but let's just take a look at this working. So you have an inlet for the air pressure, you have an exhaust valve next to it, the little cylinder is connected to a piston on a crank, and obviously once it gets started, the weight of the flywheel should keep everything running. So let's just give it a go. So as you can see, it's a lovely simple design. It's not actually my design. I will post a link. I think it was someone called Steve's Workshop that has the plans for this. So I'll leave a link for the plans in the comments section. So let's just break this down and take a closer look. So I've already laid out the parts I've created to make a nicer version than this little test rig. I've just put this on a frame and drilled some holes in it just to prove the proof of concept, if you will. So the way it works, let's start with the main body. So this is the equivalent to this frame here. As you can see, it's just a block of brass. I've slightly changed the inlet. On this one, the inlet is on the side, but for this I actually put the inlet valve on the very top. So hopefully you should be able to see that. So that is a blind hole drill down, and then you drill, blind hole drill down there, and then you drill through there. The second hole, if you can see, that is just the exhaust, and that goes all the way through. So I'll put the air pressure into the top and it will blow out of that hole. The next piece is the cylinder and the piston assembly. So hopefully you can see those. One fits in the other. So the way this piston actually works is you can see you have a little inlet there. And when it's mounted to the frame, so these two go together, what then happens is as this rocks back and forth, the holes match up, one for the inlet and one for the exhaust, and it keeps oscillating on the central pin between the inlet and exhaust as the piston goes round. So hopefully that makes sense. Air pressure comes in, pushes the piston down. As the piston goes down on the crank, it swivels across, and as the piston comes up, it lets the exhaust go out through the other hole. So in, out, in, out, in, out, in, out. So that's how it actually works, just on its own pivot. But what holds this against that square is just a pin with a spring attached to it. So the spring presses against there. There's a hole drilled into the center of this, and that just holds that flush as it oscillates back and forth. So just a breakdown of the parts we have, just so you can see these. So we have the main frame with obviously the inlet and exhaust and the two holes, one for the crank and one for the pivot. I've also drilled a hole into the bottom to mount it to this wooden frame. So it's quite simple, just like that. The cylinder itself is just a piece of 1-inch brass, which I've taken down to 25mm just to clean it up a bit. The cylinder has a hole all the way through of 12mm. It has a very small hole for the inlet and exhaust. And of course it has the pivot point, which is threaded. That doesn't go all the way through, obviously. That's almost all the way through, but you don't want to go through there. And also we just have a cylinder cap that can go on the top there. Now, this can be bolted in if you're planning to use steam, just with some very small hex bolts in the top. But because I'm not using steam, it's not hot, it's just pressurized air, you can actually just glue this on with CA glue, and it's plenty strong enough to make it easier. I'm trying to do this project as easy as possible, only using the tools I have available, which is a hand drill and a lathe. The piston is a single piece, just machined on the lathe to have the top, the shaft, and the little crank connector at the bottom. So that's relatively simple to create. Again, this is 12mm for the actual piston. And then this hole is about 3mm. Of course, to push it all together, we then have the pivot shaft with just a small bolt on the end. Hopefully you can see that. And then that goes through the frame and just screws into that pivot point. So for the crank, the components we have, I'll just put them all together because it's easier to see. So here it is. So we have a crank pin, the crank itself on the crankshaft, and the flywheel, a heavy weight to keep the engine oscillating. The way I hold the crank to the crankshaft is I've just put a very small grub screw in there. But again, if you can just glue this, it should work fine. If you've got proper Loctite metal glue, that works better. But I've tested this, and my test rig is actually built with just standard super glue or CA glue, and that works perfectly fine. So you just glue these together, obviously into the bottom hole on the frame. And that's pretty much all of the components to make this little steam engine. What I've actually added, just so you can see, is I do have a couple of little spacers to go either side of the frame, just to hold the crank and the flywheel off of the main frame, just to make them spin a little more freely. So that's just a couple of little brass washers I've just cut out. So the next question is how did I cut all of these components with just the lathe and a hand drill? So I'll take you through that now. So the first thing you would do, obviously, is just cut yourself a 30mm length piece off a 1-inch bar stock of brass. And then how do you create the flat surface first of all? So obviously one surface has to be completely flat. How do you create that? So all you would do is, once you have your cylinder of brass, you actually just mount it sideways in the lathe. So imagine that was a fresh round piece of brass. And it is that simple. Then what you would do is, as the lathe turns, you cut across that, and that will create your flat surface. So pretty simple to do that. The next step is, how do you then position how do you create the pivot hole, which has to be perfectly centered within that flat surface? And to do that, there's a couple of different ways. You can put it long ways into a 3-jaw chuck, but that won't necessarily be perfectly accurate to the center, although it'd probably be good enough. So if I pull this in, hopefully you can see that's virtually centered. But depending on the length of this, it should be 30 mil. But if you're off by a little bit, it may not center that hole perfectly. So the other option is to put it in long ways between the top jaws of the 3-jaw chuck like this. But then you just use a spacer on the bottom. So, for example, you would just cut yourself a piece of metal from your bar stock that is of the right height, and then you just put that on one jaw, let that piece drop on top of it, and then you tighten up the jaws like so, and then you should be able to perfectly center this depending on the height of this spacer that you've put on there. Hopefully you can see that. So as you can see, I've got a spacer in there. So the height of that spacer will just position this to be perfectly centered. So then you can get a perfectly centered pivot hole in there. So when you drill the center, you have to make sure that you don't actually go through into the cylinder. That's really important. So make sure you take your measurements properly. I think you've got about 5 mil of space there or so. So you only want to go in 4 mil, and then you want to create your thread there. So as an example, this is just an old test piece. Let's put the hole in. As you can see, it's easy to create a hole in there, which you can then tap. So I swapped over to my 4-jaw chuck. To do the actual frame, obviously you've got the 2 main holes, the pivot hole and also the crank hole. To do those, I actually did those on the 4-jaw chuck because I didn't like having this bar of metal in the 3-jaw. I couldn't quite center it properly, so it's just a bit more accurate. Because this is an independent chuck, you can adjust the jaws to get it exact. So that's how I actually did these 2 holes, and they're really precise and square. Obviously, every time you put something into the lathe, make sure you square it up correctly. The way I actually square things up is I have a piece of aluminium that I've cut perfectly square. Hopefully you can see that. And then using the drill chuck, I actually just push these together to center it, and the 2 flat surfaces will push the piece in square. I hope that makes sense. Yeah, so if I pull, let me just loosen this. So if you pull this forward slightly, and then what I do is I put this piece of squared aluminium bar stock in, and then I slowly push the piece against that, and that will square it perfectly. And then I can just nip up the jaws to make it tight. So that's how I actually square quickly and easily on the lathe. Now the good thing with this project is it doesn't have to be too accurate. In fact, you don't want very tight tolerances because it will probably be too tight to run anyway. I've actually found on my test rig having slightly loose tolerances and maybe making the shafts 0.1 of a millimetre smaller than the actual hole, the whole thing just runs a little easier. So you don't have to be really tight with the tolerances. So that's how I did that. The bottom hole, for mounting to the base, I just put that in long ways. You can do that in the 3-jaw chuck. The reason it's off center is I did it on the 3-jaw chuck and I balanced it on the bottom jaw. And then all I need to do is on the base, I just create a small offset rather than putting the screw in perfectly in the base. So that's how I did that. The next step is how did I do the holes, the exhaust holes and the inlet hole. So let's take a look at that now. So nothing fancy here. I just hand drilled these. Remember the inlet hole for my design, I'm actually going to make the inlet on top of the frame rather than on the back. So this, the inlet hole should not go all the way through. It should only go halfway through this base. And then you connect the hole up through the top. Whereas the exhaust hole can just go all the way through. And it is that simple. I just held my drill straight, no pillar drill required. Again, the accuracy is still good enough. Now, how did I line these up? So if we take a look at the cylinder again, we've got the pivot hole, and then we have the little inlet and exhaust hole. So the way this works, the exhaust hole on the plans are 1 centimetre or 10 millimetres above the pivot hole. So the way you do that is before you do the pivot hole, you can actually just score in a line. Does that make sense? So you can see where it will be on here. So 10 millimeters on the center. I line that up and then I just pivot in the pivot hole to draw the nice line, and then the two holes are actually 5 mil apart, but 2.5 millimeters from the center line. So you have the center line with the two main holes, and then the inlet hole is 2.5 millimeters one side, and the exhaust hole is 2.5 millimeters the other side. Hand drilled. It's very simple. All the other components are just standard lathe work. For example, the single piece for the piston and rod, the pivot with a small thread on. The flywheel is just a heavy piece of steel. I happen to have an old piece of stainless steel that I've just rounded off and polished off. And that's it. So all that's left to do now is I just want to polish all of these parts, one last polish and sand, and then we'll assemble it and see if it works. So here's all the parts. Let's get it assembled. So there it is, the completed engine. As you can see, if you're just using compressed air, it's really easy just to use glue. It worked on my test rig, so I have no reason to believe it won't work here. But if you want to use steam, then I'd recommend putting bolts into this cylinder cap just to hold it tighter. And any glue you use, make sure it's heat resistant so the hot steam won't break the glue down and make it fall apart. So I just added this extra nozzle on top, which 7mm OD, just to match the nozzle of my compressor, my air compressor. So I'm happy with this. However, there's one thing that I'm not happy about. This little spring tensioner nut on the pivot shaft. I don't want to use this little nut. I'm going to make myself a nice brass one. So let's jump on the lathe and make a brass nut with an M6 thread. Just going to use the knurling tool to put a pattern in there, just something to grip on. So I made a small knurled knob. Hopefully you can see that okay. It looks pretty good. Pleased with that. So let's just finish this off. Right, and let's just give it a final test. So thanks for watching this build. I'm really pleased with how this has turned out. It looks really good. If you have any questions on how to build this or you're struggling, just leave a comment in the comments below on my YouTube channel. But for now, thanks for watching, and hopefully I'll catch up with you soon on the next project. Most likely going to be steam engine related because I really enjoyed this. So see you for now.